Hey folks, I'm Shub, and today we'll be going through how you can create your own cross-chain multisig using Axelar. So first, let's understand what we'll be creating. So we'll be coding two smart contracts which will be on two different or distinct chains. On first chain, we will create the base structure of the contract which will have its name, its owners, its owner's address, the funds which it can store, and the status of the signature of their owners. Then we'll have a function which will be doing a general message passing using Axelar to second chain to facilitate the safe creation and to set the owner on the second chain. And whenever the second owner on the second chain will sign a transaction of approval or disapproval on the second chain, that message will be passed to the first chain using Axelar. So let's deep dive into it. This is a basic structure of like what a user can do. So they can get safe info, sign transaction, withdraw funds, add funds, and create safe. And we'll be using Axelar's general message passing for cross-chain communication. Now let's understand what Axelar or Axelar network is. So Axelar is a decentralized network protocol that aims to connect and enable communication between different blockchains that can be EVM or non-EVM like Cosmos chains, facilitating cross-chain interaction and composability in Web3 space. These are some key points that Axelar covers like cross-chain communication, asset transfer, cross-chain execution of functions, decentralized ecosystem, and it have a large number of supported chains like Ethereum, Avalanche, Polygon, Phantom, and other chains. So what's Axelar's general message passing is? So using Axelar general message passing, you pay a gas fee on the starting or source chain to facilitate the transfer, and you can create or encode a particular payload which will be transferred to the destination chain on the destination contract, and you can save data which is being sent from source chain to destination chain on the destination contract. So basically that is what we'll be leveraging in today's general message passing contract. So these are some key points of general message passing like cross-chain asset transfer, cross-chain smart contract execution, and cross-chain data exchange. Using Axelar, we can also pass tokens with the message. So general message passing with tokens is also possible with Axelar. Now let's start coding. So in first step, what we'll be doing is we'll import the libraries of Axelar which we'll be using in a contract, and we will extend our call contract with Axelar executable so that we can use the particular execute function in Axelar executables. In step 2, we'll be creating a constructor or declaring a constructor with a gateway and receiver. So every chain on Axelar has a different gateway and receiver. Let me pull you a link. So if we go here, so in this is the Axelar's documentation, and it have two tabs, that is mainnet and testnet contracts. So in testnet contracts, if my source chain is on Avalanche, then the gateway and gas receiver contract will be these addresses. If it's BNB, then it will be these addresses. So right now, let's suppose if we are deploying our source contract on Avalanche, then the gateway and gas receiver will be of Avalanche. Then we are declaring a token with an IRC20 interface. So this token address is a token which I deployed myself on Avalanche, and you can check it on the Avalanche node trace chain about this particular address, and we'll be using this to add and withdraw funds into the safe. In step 3, we are declaring a struct which will be storing the basic details about the safe, like the safe name, the addresses or the owners of the safe, the status. So like the status variable is used when to check or to store the signing status of the particular address. Let's say if address 1 have accepted the transaction, then the status 1 will be true. And the timestamp is the values of whenever a particular withdrawals are performed. The balance is the balance of ERC20 token which the users will deposit into the safe. If you want to use USDC to store in your safe, you can declare USDC, or if any ERC20 token can be compatible. You just have to tinker the smart contract once. Up next, we are having a create safe function. So like create safe functions take some parameters like safe name, Second signer, the first signer will by default be message.signer. The destination chain on which the second contract will be, let's say BSC testnet is the second chain, then the destination chain will be Binance, and destination address will be the address of the smart contract on the destination chain. It's external payable. We are keeping it payable because we need to send some funds to accommodate the cross-chain transfer of the message. So whenever a new safe is created, a unique safe ID is assigned to it, and we are creating a message that, let's say, a safe ID with safe ID 10 is created and its second owner's address is X. Now this payload is being passed using Axelar's general message passing to the second contract that is on BSC testnet, that a new safe with safe ID 10 is created and the second owner is this particular address. Now that address can just go to the contract on BSC testnet and can enter the safe ID that I am a safe owner of safe ID 10, and can just accept the transaction, and after that particular acceptance will be sent from that particular chain to our base chain, that is Avalanche, that the second owner has accepted the transaction. So this particular part, what it will do is it will create a payload and send the data that a particular new owner is been created for a safe. We need to give some gas fees to it. So if here's a transaction, so if you see here, then this particular gas was charged. So if it's an Avalanche, you can see like what's the gas charge for Avalanche and use it into your contract. And as you can see, it's being sent from BNB to Avalanche and from Avalanche to Optimism. So yes, I think this is good for this particular part. We are encoding the safe ID and second signature, and this will be sent to the underscore execute function on the destination contract. After the successful sending of message and safe creation, we are returning the safe ID of the new safe. So in step 4, you can add funds in a particular contract or a safe ID. So if I am a safe owner of safe ID 10, then I can add X amount of tokens into that particular safe. One thing is I need to sign the approval of approved to like withdraw tokens from my account on the particular IRC20 token which I mentioned before, and set the approvee as my current contract. And after this, like my balance in the particular safe ID will update that the new balance will be the amount which you are sending to this particular contract. Now we have funds into the contract. Let's see how we can withdraw it. So withdrawal has two specific conditions. First is that the first owner of the safe needs to agree that this particular withdrawal can be done. So the first owner can sign the approval transaction on the chain 1 itself. So they can use set approval function and give the safe ID of it they are owner of, and can just sign it that yes, I accept the transaction. And we are also emitting an event. These events are being emitted by every function. Further, like if we want to like leverage those events in notifications, then we can code notifications on top of push protocol to catch these events and to send payload according to that. Now let's assume that first owner has approved the transaction. Now let's go through the execute function on the receiving side. So in step 6, we'll be creating a function to receive signing status of second signer from second chain. So we have approval of first signer, that is on first chain. Now let's assume the second owner on second chain have also accepted a transaction, and that particular acceptance or rejections will be sent using Axelar general message passing, and we will be catching that into our smart contract on chain 1, that is Avalanche, using execute function. This execute function is decoding the payload and setting the value in the safe ID and status as particular values which will be set. So like let's say with safe ID 10, the boolean status is set to true. So in this particular contract, the safe ID with ID 10 and its status will be set to true. And this is an internal override function, so it cannot be called by normal anyone publicly, but it needs to be called by the Axelars itself, as we are inheriting it from the Axelar executable. Further, we are checking if the status of both the safe owners is true. That is, if the safe owner 1 and safe owner 2 have accepted the transaction of withdrawal, then we will be calling the withdraw function with the safe ID and whatever balance is in the safe, and to which address the funds need to be transferred. So right now we are keeping it to A1. If you don't want it, then what you can do is sign the transaction on safe 2 first, then the safe 2 status will be set to true, and later on sign the transaction on chain 1 later on, so that you can manually call the withdraw function on with the particular safe ID, the amount which you want to withdraw, and the address to which you want the funds to be withdrawn. So here we are checking if the owner who is calling the particular withdraw function is one of the owners or not, and if the signing status of the particular safe is set to true or not. So like, let's say if one safe owner have accepted a transaction but the another haven't, so this transaction won't go through, it will be reverted from here itself and it will give error. Then we are checking if the amount that is being asked to withdrawn is less than or equal to the balance of the safe or not. If it's greater than the safe balance, then we won't let it go through. Let's say the safe balance is 100 USDT and the user is asking to withdraw 1000, so that won't happen. It will be reverted from here only, as the balance is not matching. After checking both of these conditions, we are doing a transfer function from to this particular address, and we are sending this particular amount, whichever is requested by the owner in this amount function. Then we are emitting an event that the money has been successfully withdrawn. We can catch it in our push protocol showrunners framework and trigger a notification on with the help of it. Up next, we are setting status of both the safe owners as false, so that this function cannot be called again, and both the owners need to sign the transaction or true for the withdrawal of funds. Then we are resetting the balance, and we are setting the balance as minus amount, as this particular amount has been withdrawn from the balance. Let's say 10 USDC is withdrawn from a balance of 100, so the new balance will be 90. And we are adding the current timestamp into our timestamp array, so that we can keep a ledger of the withdrawals which are happened on particular safe. Same summary is being mentioned here, you can read it peacefully. So this is, here we come to the end of the first part. If you have any doubts, you can feel free to reach out to me on my Telegram. And here you can find the full contract link. So like, this is the full contract, you can have a look on here and let me know if you have any doubts. Let's go to the part 2 of the cross-chain multisig part. And so like, in the first part we created a contract on chain 1 and we sent a cross-chain message using Axelar GMP in our create safe function. And now what we'll be doing is, we'll be create a new contract and deploy it on a separate blockchain, that can be BSC testnet or Optimism or any other chain, which will be referring to as chain 2. The contract 2 will serve as a registry to record so it will act as a registry to keep a mapping of safe ID and their owners. Now let's go to step 1. So as we have seen in the past contract, we'll import the libraries. We'll create a contract with a constructor which will be taking a gateway and gas receiver. Now this gateway and gas receiver will be of BNB testnet, as we are choosing it as a second chain. So here the gateway will be this and the gas receiver will be this. Up next, in the step 3, we are creating a execute function. So this execute function will be called by Axelar whenever a new safe is created on the base chain or the chain 1. So let's say on chain 1 a user creates a safe with safe ID 10 and the second owner's address is X. So this execute function will be called by Axelar's general message passing, and it will set the safe ID and its owner on this particular current safe, so that the second owner can come to this particular contract and he can say that okay, my safe ID is 10 and I accept the transaction. So in this way the transaction will be accepted. So up next we have a set status function. So set status function is used by the second owner of the chain. They will mention the safe ID, the destination chain, that will be avalanche in our case, and the destination address, that will be the smart contract address of the contract on chain 1. And here like we are checking if the message.sender or the user who is calling this function is the real owner or the second owner of the safe or not. If not, we'll revert the transaction and give a into the spotted error, or else we'll let it go through and set the signing status as true. And we'll send this signing status as true to the first chain or to the avalanche using Axelar's general message passing. You need to pay some gas on it, as we seen before, like you need to pay 0.001 BNB as gas for this transaction to go through. And in the execute function, like you seen before, like this one, we'll have a same on the avalanche contract too, and that will set the signing status of the second owner as true. And after that, both the owners have accepted a transaction and the transaction would go through, or the funds can be withdrawn from the safe. So here's a quick summary about the particular function that is mentioned before. And if you are thinking how you can estimate the guess programmatically, here's a link to Axelar's documentation, so you can also see that to get more info about that. Further, we have two getter functions. So like first is used to get the status of a particular safe. So if I want to check what's the signing status of safe with ID 10, I can just give the safe ID and it will return me its status, that can be true or false. By default it will be false. And second is the get owner, which can be used to get the owners of particular safe. So like let's say I want to know who's the safe owner of safe with ID 10, then this will return me the owner. So this is pretty much about the second contract also. Second contract was basic as compared with the first contract. It's less complex as we don't have any add functions or withdraw functions. You can feel free to add it if you want. The code is all open source, and I have also mentioned the code for the second part here. Again, if you have any doubts, you can reach me. Feel free to reach me out on Telegram. So this cross-chain multisig can be useful for the people who have funds on a particular single chain and they don't want to bridge, or they just want to stay on their chain and they say like, okay, I'll do whatever you say, but it's going to be my chain. So using something like Axelar general message passing, you can do that and like pass cross-chain messages and build application on top of it. I hope you like this. Enjoy. Have a good day. Thank you.